Hello and welcome back to our course. So in the last session I introduced multi-dimensional Numpy arrays, and the most common case is the two-dimensional case where we have rows and columns. So in this session we learn how to index and slice two-dimensional arrays and also how to change single or multiple elements in a two-dimensional array. But first of all, let's as always import Numpy. And then we create a Numpy array from 1 to 12 including. And then we reshape those 12 elements to 3 rows and 4 columns. Now you could ask yourself why the elements are arranged in this manner. So we have kind of a row-wise order. So we have 12 elements, and reshape automatically orders the elements row-wise. So starting in the first row 1, 2, 3, 4. Then the second row 5, 6, 7, 8. And theoretically it could also be the other way around. So starting column-wise, so 1, 2, 3, 4, 5, 6. And the answer is that this is a default setting in Numpy, but of course we can change it. So in the reshape method there is a parameter called order, and it's the default setting is C. I don't want to go into details what C means, but we can change here the order to F. And when we rerun here our cells, then we get a different order. So now we have 1, 2, 3, 4, 5, 6 and so on. So this is flexible here. Alright, so let's rechange it to order C and run the cells again. Now again we have our, let's say, normal order. And indexing multi-dimensional or two-dimensional arrays, there's actually no difference to one-dimensional arrays. So we have also zero-based indexing, and if you want to slice the first element of the array, so the first element here is the first row, we can do this by having the 0 in square brackets. And now we get the first row of our array. And we can also get the second row at index position 1 and the third row at index position 2. So here we have index position 0, index position 1 and index position 2. And we can also slice the last row, which is actually the third row. This gives us the same result. And what if now we want to slice in the second row the second element? So let's say here, so we want to have in the second row, the second element, the 6. And we can do this by having 2 square brackets. So first of all, let's cross the second one here out. So first of all, we are slicing the second row here. And then from the second row, we are getting the second element at index position 1. And actually we do not need 2 square brackets. We can put this into 1 square bracket separated by a comma. So the first position gives us the row we want to slice, and the second position gives us the column. So square bracket 1, comma 1 should give us the same result as here above with 2 square brackets, and yeah, that's correct. So now we can also index the element in the third row and the last column. So let's see what it is. So in the third row, in the last column, it's 12. Let's check this out, and we get 12. And now what if we want to select a column? So all rows and all elements in a column. Then we can say, okay, I want to have all rows. I have a double colon, and then I want to have the first column. Now this gives us the complete first column, 1, 5 and 9. So all rows in the first column. And of course we can also select for all rows in the second column, 2, 6, 10. And also all rows in the last column, 5, 8, 12. Now we can also do more complicated things like getting the elements in the first 2 rows in column 2 and 3. So in the first two rows, the elements 2 and 3, so 2, 3, 6, 7. Yeah. Alright, so let's go back to our array A. And what we can also do, we can switch or change the axis or transpose the axis. So to say that, yeah, instead of having here 1, 2, 3, 4 as the first row, we want to have it as the first column. And instead of having here the first column 1, 5, 9, we want to have it as the first row. And we can do this by the attribute T. So T, capital letter. And there we see we just transposed our ND array, or we switched the axis. And there's also the method transpose. So here with the brackets you can see it's a method, not an attribute. And this gives us the same result. Alright, so now let's go back to our ND array A. And let's assume we want to divide the last column by 4. And actually we want to change the last column. So let's first of all divide all elements by 4. So we select all rows and the last column, and we will divide each element by 4. And then we have to assign the new values to the last column. So we have to say, so please, for the last column, please calculate new values. And now if we check A, there you can see, so in the last column, we have divided all elements by 4. Okay, so let's rearrange our array A. We know it already, and then we can take the sum of all elements. So there's the method .sum, which sums over all elements in the matrix. So it's 78. And what we can also do, we can take the sum of each column. So we can take the sum of column 1, it's 15, of column 2, it's 18, and so on. And therefore we have to define the axis. So the axis is an argument or parameter of the sum method. And axis equals 0 means that we take the sum of each column, or to say along the rows. So we sum up along the rows. Let's see what we get. So we get 15, so 15 is here the sum of the first column. We get 18, it's the sum of the second column. 21 is the sum of the third column. And 24 is the sum of the fourth column. And we can also take the sum of each row. So this means we take the sum along the columns. So we get 10, 26, and 42. So the sum of the first row gives us 10. Then the sum of the second row gives us 26. And the sum of the third row gives us 42. There's also the method CumSum, and CumSum returns the cumulative sum of all elements. So let's see what we get. So cumulative means we are starting from the first element, so 1. Then we are adding the second, gives us 3. Then we are adding the third element, gives us 6. Adding the fourth element gives us 10. Adding the fifth element gives 15, and so on. And we can also take the cumulative sum for each column. So now let's check here the first column. So we start with 1, then we add 5 to 6, then we add 9 to 15. And also the second column we have 2, adding 6, then we have 8, adding 10, then we have 18. And we can also do the same cumulative sum for each row. All right. So let's go back to our initial array A. And there's also the method .prod. So it takes the product over all elements. It's a bit a large number here actually, and we can also take the product over all elements in each column. So axis equals 0. gives us the product of the columns. So here we have 1 times 5 times 9 give us 45 and so on. So 2 times 6 is 12, times 10 is 120. And yeah, of course we can also take the product over all elements in each row by having the parameter axis equals 1. And there you can see it's the product here over each row. So 1 times 2 times 3 times 4 gives 24. Yeah, and so on. Alright, so this is it for this session, and in the next session we learn about Boolean indexing. So hope to see you there. Bye.